Hello guys, with the name of God, Ram Ram. I am Kumar K, your favorite teacher for basic to hard level DSA plus OA plus CP. So, today we are going to have lots of fun. We are basically going to solve the two tree problems were asked in Cisco online assessment. I will be giving you guys the video solution for both of them because you guys requested a lot for it in the past videos, and I really got so many messages and comments for it. So we are going to enjoy the Cisco online assessment problem which was asked for CTC 28 lakhs on 24th June. Okay. I will give the link to the previous video also. And in the past, I have made OA videos of Cisco OA videos are there in abundance on our channel and also in our 850-hour course. So I'll try to link as much as possible here, and I will also try to link all the Cisco OA questions we have collected till now. Okay. And guys, sorry for no video for from last few days because guys, it's the placement season going on and I'm very busy with my day life training, one-to-one mentoring, and trying to solve different OA and CP questions. I have to do that all day to keep the program running and to keep helping students all the time. For example, from last few hours I was solving this problem. It's such a difficult problem. Its name is Iris and game on tree on code forces. So I had made up my mind that only when I am completed solving this problem, only then I'll record this video. So, yes, I have solved that problem. So now let's go to the Cisco online assessment. I'll try to give you guys the best possible visuals. Okay. So, guys, first let's go to the understanding of the problem. Ram Ram. So, what I'm trying to say is that in this particular problem, you can read this big problem given to you. I will just make it easy for you. So they are saying that you are given a tree. Okay, you are given a tree of n nodes. Okay, you're given a tree and the tree has n nodes, guys. Okay, some nodes have their value as 0 and some nodes have their value as 1. Okay, what is your task? You have to find a path where you start at some particular node. Okay, you visit some edges and then you get back to the starting node. One more thing which we need to take care of is that this this traversal should contain all the nodes whose values are 1. This traversal should contain all the nodes in the original tree whose value was 1. 0 nodes are also allowed, but none of the 1 value node should be getting missed after the traversal is done. Okay? Okay, sir. Then what? Try to find the shortest path possible. Try to find the shortest path possible. Okay, so this is the problem. So, like, whoever is watching this video, you might be a beginner in DSA programming, you might not be knowing the concept of trees. So I've created this brilliant prerequisite course for you people. I want you guys to go through this prerequisite course and mainly go through the tree section of the prerequisite course. Like, मेरा विश्वास करो, इसको आप देखोगे तो आपका माइंड एकदम क्लियर हो जाएगा. इसमें आपको नीचे स्क्रॉल करना है, आपको दिख रहा है मेरे प्रीमियम वीडियोस वार्म अप कोर्स फॉर डीएसए ओईसीपी. आपको बस ये 5 वीडियोस देख लेनी है और मोस्ट ऑफ द डीएसए ओईसीपी के आपके ट्री के क्वेश्चन सॉल्व होने लग जाएंगे. बहुत ही अलग स्टाइल से पढ़ा है. ट्राई टू वॉच देम. जनरल ट्रीज, नॉट टॉकिंग अबाउट जस्ट बाइनरी ट्रीज व्हिच standard DSA sheets contains. Okay, the influencer stuff, I don't want to do that. I want to become the correct person for you. So make sure you study trees from here and then you watch this Cisco A video. Okay, so I'm mentioning the prerequisite here already. So like most of the people who already know me, they know that they should do this prerequisite course before watching any of my videos. Okay, So now I assume you know everything about trees, so let me draw some tree and try to tell you what they are trying to tell. Okay, so they are saying that a tree like this is given to you. Okay, a tree is given to you. Okay, some node values are 1 and some node values are, let's say, 0. Okay, and let's say this value is, let's say, 1. Okay, and let me try to solve the easy version for you. The easy version, if I try to solve, it will really help most of the people here. Okay, so guys, ones and zeros are given to you. Now what will you do? Let's try to solve the easiest version possible, because the easy version will really make it very very easy for you people, trust me. Okay, trust me. So the easy version is that from any node in your path you can visit any other node at a distance of 1, at a distance of 1 at a distance of 1 to collect coins from some other node. So they are just trying to complicate things for you. Why are they? Sometimes when reading the question, now the hard unseen DSA question, when you are checking this question, you will not find in the standard popular DSA sheets. Try to see क्या बोलना चाह रहा है. वो बोलना चाह रहा है कि पाथ ऐसा होगा कि तुमको घूम फिर के वही पाथ पे आना है. Means each edge you can visit 2 times on that path. It does not matter. Okay, and then like, even if you cancel the previous statement, let's cancel the previous statement for some time. They are just trying to ask you for the shortest path. So now you only use your brain and you only tell me which path will you go through. Like, this is node 1, 2, 3, 4, 5, 6, 7. Which path will you select to make sure all the nodes with value 1 get traveled? This node has value 1, this node has value 1. Answer is, I will travel from node 2 to node 4, and this will solve the question. Why? See, node 2, node 4. Node 2 also has a value of 0. Node 4 also has a value of 0. So, I will travel from node 2 to node 4, and then again from node 4 to node 2. This will be the actual part, 2 to 4 and then again 4 to 2, because it is written in the question that wherever you started traveling now, you need to go to the original node again. So can you think and tell me that why is the path 2 to 4 and then 4 to 2 is a valid path? Well, I will tell you. See, when in this path, when I'm at node number 2, they told now that you can collect the any coins. Okay, you can collect any coins are nothing but of value 1. You can collect any number of coins you want which are at a distance of 1 from the any node in the path. So जब मैं node 2 पे हूँ, when I'm, see, my path is this. Okay, my path is the blue color. In this blue color, when I'm at this node number 2, I can just take this one coin now, because it is at a distance of 1. And when I go from 2 to 4, when I go from 2 to 4, I am at node 4. So I can just pick up the coin of value 1 from node 5, because the distance between 4 and 5 is 1. So the path is nothing but 2 to 4, and you have to visit it 2 times, 2 to 4 and then again 4 to 2. So you have visited this edge 2 times, so the shortest path length is 2. Just by visiting 2 and 4, you are able to collect all the coins. Coins means you are able to collect you are able to touch all the nodes. You are able to touch all the nodes whose value is 1. Okay, so if I try to write the definition again, you have to find a path where you start at some particular node and you visit some edges and then you get back to the starting node. This traversal should contain all the nodes. This traversal should be able to touch or contain, should be able to touch or contain all the nodes whose values are 1. So I will show you more examples. Now it's clear in your brain. You are a Kumar K student, man. Let's say it's like this. Let's say things like we need to make a tree, right? So let's say the tree is like this. Okay, this is the tree. Node 1, 2, 3, or 5, 3, 4, 6, 7, 8. Okay. Um, Let me give it a numbering like this. Now, guys, you can actually feel it, right? Ram Ram. Okay, I like the old numbering only. Okay. Or we can use this numbering also, no problem. But let me try to use the old numbering 2, 5, 3. Like, let me put here 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now, guys, use your brain and tell me what path should I travel so that I can touch all the nodes whose value is 1. Whose value is 1? Node number 1, node number 3, and node number 4. What will be the path which, if you travel, you can touch all the nodes, which is node number 1, node number 3, and node number 4? The answer is that you will travel the path 225. Why? See, the answer is that I should just travel the path 225 and then again from 5 to 2. Okay, you can even write it like this. Why? When I'm at 2, I can touch 1 na, because I can touch the node 1 because it is at a distance of 1. When I'm at 5, I can touch 3 also and I can touch 4 also. And all the nodes with value 1s are getting destroyed, man. So, like, that is the actual meaning of the problem. If you read, you will understand that they have said the same thing. Alex can collect all coins located within a distance of 2 edges from X. Okay. So, whatever is your path, na, like 2 to 5 was the path, matlab they are saying that we can collect any coins at a distance of 2. I am saying let's solve the easy version. The easy version is where you can collect the coins of value 1 at a distance 1 from your path. So if my path is 2 to 5, I can just when I'm at 2 I can destroy node 1, and when I'm 5 I can destroy node 3 and 4, because 3 and 4 are at a distance of 1 from 5 and node number 1 is at a distance of 1 from 2. So hopefully these things are clear to you, lovely, lovely student. Okay. Okay, so there could have been many, many different cases, Ram Ram. Let me try to think and make more test cases for you lovely people. So let's say this is one. Node 1, 2, 3, 4, 5, 6, 7, 8. So the question is pretty simple. You want to touch or contain all the nodes whose value is 1. So you want the shortest path where you can start at some node and end at some node, but you should make sure you contain all the nodes whose value are 1, or touch all the nodes whose value are 1. So you need to touch node number 1, node number 4, node number 8 and 7. 1, 4, 7, 8. You have to touch 1, you have to touch 4, you have to touch 7 and 8 because their values are 1. So what is the answer? Someone can say, sir, answer is 2 to 3, sir. I will go from 2 to 3 and then I'll go back from 2 to 3. Let's see what happens. When I'm at 2, I can destroy node number 1. Then when I come to 3, I can destroy node number 4. But guys, this is not the correct answer, because in this path, you can never destroy node number 8. You can never destroy the node number 8, guys, and node number 7. Why? Because node 8 is at a distance of 2 from 3. So unfortunately, guys, very sorry to tell you that 2 to 3 is not a correct answer. Then what is the correct answer, sir? Correct answer is, you guessed it right, 2, 3, 6. You need to visit all the nodes 2, 3, 6. Why? 2 to 3, 3 to 6, and then go back. Simon, go back. 6 to 3, and then 3 to 2. You need to do something crazy like that. Okay? So, like, this is the connected component of nodes. Okay? And each edge is getting visited 2 times. It is common sense. You have to do that on a tree. Yeah, like, if a tree structure is given to you, let's say you are traveling a subtree. Okay, let's say you are traveling the subtree like this. You go from here, like here. Then you need to come back like this. Then like this. Then come back, and come back. So the once you have decided your path, na, this is the first observation. Let's say this is your start node and this is your end node, because you come here only. The path will always be what? 2 into the number of edges. How many edges are there? 1 edge, 2 edge, 3, 4, 5, 6, 7. 7 into 2, 14. हर एज को आपको एक बार लेफ्ट से राइट जाना पड़ेगा, फिर रिटर्न भी आना पड़ेगा. Each edge you will have to travel 2 times in this particular case. So 2, 3, 6 is the correct answer. Why? Because when I'm at 2, before going to 3, I can destroy 1, and when I come at 3, I can touch 4, right? Because it's at a distance of 1. When I'm at 6, when I go from 3 to 6, I'm at 6, I can destroy 8 and 7. Why? Because both of them have a distance of 1 from 6. Then I'll go from 6 to 3 and 3 to 2. So, the analysis is clear. Whenever we select a proper subtree of the original tree, like, subtree means not the standard rooted subtree definition. Okay, subtree means any part of the tree. Okay, whenever we select a proper subtree of the original tree, answer is nothing but what? Answer is 2 into the total number of edges. 2 into total number of edges in that subtree. So guys, what is the first observation? The first observation is, all the leaves which have value 0, they do not matter. You never need to travel them. So remove them, and rest of the tree is the answer. See, such a nice question it is. In this example only, guys, what is a leaf? Like, if the tree is not rooted at some node, leaf is nothing but any node who has a degree of 1. Leaf is a node whose degree is 1. So let's check which are leaf here. So guys, this is a leaf because node 1 is only connected to one other node. So it is a leaf. 8 is also a leaf. And then 5 is also a leaf. 7 is also a leaf. So the question is saying just delete the nodes. Just delete the nodes which are leaf and having value as 0. So guys, only this node, node 5 is a leaf whose value is 0. So destroy it, delete it. So guys, after deleting it, whatever is the tree, na, that is your answer. This is our answer. How many nodes are there in this tree now? How many nodes are there in this tree? Now it is sure that all the leaf nodes are 1. When you have deleted all the leaf nodes with value 0, all the leaf nodes are 1. So what is the total number of nodes here? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 7. Out of these, how many you need to subtract? You need to subtract all the leaves whose value is 1. So 1, 2, 3, 4. इनको तुम डिलीट कर सकते हो, इनको ट्रेवल करने की जरूरत ही नहीं पड़ेगी ना. 7 minus 4, 3. 3 is the answer. See, 3 length smallest path, right? 2 to 3, 3 to 6. So 3 multiplied by 2 because the edges you have to visit 2 times, na. So 3 node path, 3 node subtree we have finally got. 3 nodes means there will be 2 edges. Multiplied by 2, 4 is the answer. So if I try to explain it to you in some easy language, na, let's say your tree looks like this. Okay, so just let me try to make a very nice tree for you people. This is your tree. Okay. Now, which are the leaves? Which are the leaves or a leaf? Many nodes are leaf. This is a leaf. This is a leaf, and this is a leaf, and even this is a leaf. But guys, we only care about those leaves whose value is 0. This is a leaf whose value is 0. So what will I do? I will delete it. Now in the remaining tree, is there any leaf whose value is 0? Now this has become the leaf. This has become a leaf because this node is deleted. So this node has only a degree of 1. So this is also leaf. So delete the new leaf also. Delete this. Is this 0 a leaf? No, because there are the degree is 2. See, it is connected here. Degree 1, degree 2. It is connected to 2 other nodes. So now there is no leaf whose value is 1. So this is the answer. This structure we need to visit in the minimum number of edges. This is what? Answer. In the answer, it is always guaranteed that each leaf will have a value of 1. So you can see in our answer, each leaf, this leaf also has a value of 1. This also has a value of 1. This also has a value of 1. So total how many nodes are there? 1, 2, 3, 4, 5, 6. 6 nodes are there. How many leaves are there? 3 leaves are there. So subtract the 3 leaves. 3 nodes you need to visit. Basically, apart from these leaves, you need to visit these 3 nodes, na? So total number of nodes in the remaining tree minus the number of leaves with value 1 in the remaining tree equal to is the answer. 3 nodes you need to visit. To visit 3 nodes, how many edges are needed? N minus 1, 3 minus 1, 2 edges are needed. You can see edge 1, edge 2. Year to year, year to year. So you need to visit the edges 2 times. So year to year back, year to year back. So 2 multiplied by 2, 4. You have solved the problem, baby. So the next thing which is very very important is that once you remove all the nodes which are leaves with value 0 in this new tree, you might find new leaves with value 0 delete them again. You can just like even basic DSU you can use for this. Okay, disjoint set union, BFS DFS recursion or something like that. Just keep on delete them again until you get a tree whose all the leaf nodes have their values as 1. That is what you will reach guys. अगर तुम बार बार ट्री के अंदर से सारे लीफ डिलीट करते ही जा रहे हो जिनकी वैल्यू 0 है, तो घूम फिर के एक ऐसा ट्री मिलेगा जिसके लीफ वैल्यूज 1 है। तो जो लीफ वैल्यूज 1 है, ये पूरे ट्री को ट्रेवल करना है। तो ये पूरे ट्री को ट्रेवल कैसे करोगे? कितने नोड्स है? 6 नोड है। तो 6 नोड को ट्रेवल करने के लिए इनमें से जितने भी लीफ है उनको माइनस कर दो, क्योंकि लीफ को विजिट करने की क्या जरूरत है? You can just visit the other structure na. The other structure will make sure you can jump one step and collect the coins of the leaf, right? Yes baby, yes. So the final answer will be what? Final answer will be total number of nodes in remaining tree minus leaves in the remaining tree. Okay, whose all values are 1. Okay, that you already know. Okay, so whose all the leaf nodes, whose all leaf nodes will have value 1. So this is the remaining structure, right? Final answer will be what? Final answer. So like this thing, like this is the total number of votes. Okay, so final answer is what? This is the number of nodes you have to visit. So what you can do is, edges will be what? Edges which you need to visit will be nodes minus 1 multiplied by 2. Nodes minus 1 multiplied by 2. So like final answer, whatever in the final answer I means the node number of nodes, minimum number of nodes you need to visit. So if you know that these many nodes you have to visit, then just do nodes minus 1 into 2. That is the total number of edges you need to visit in your path. Okay. So you have solved this problem lovingly. Okay. And the most important thing, I just removed the zeros because zeros leaf are never need to visit na. Common sense hai. If there is a node, let's say this is a tree, okay, let's say this is 1, this is 1, this is 0, 0, 0. So which nodes I need to travel all the ones, or I need to touch all the ones in my shortest path? 1 means you don't need 0. You never need to visit a path which is having 0 at a leaf. So can you see leaf here? 0, 0. अरे इसको ट्रेवल करने की क्या जरूरत है? हमको तो 1 चाहिए ना, तो इसलिए इनको डिलीट कर दिया पहले. So tree can get smaller. I deleted this. Now this is the tree which I have, right? Okay, lovely student. But still there is one more leaf. Now this is the remaining tree, right? ये भी तो एक लीफ है ना, because its degree is 1. तो इसको भी डिलीट करो. Now this is the remaining tree. This tree is a good tree. Why? Because all the leaf values are 1. Total how many nodes are there? 3 nodes are there. So answer is 3 minus how many leaves? 2 leaves. So only one node you need to visit, which is this node. When you come at this node, you can touch this also at a distance of 1, and you can touch this also at a distance of 1. Done, done, done. One node means you need to visit 0 edge. 0 multiplied by 2, 0. 0 edges bhi kaam ban gaya. Wow. So guys, you have solved the problem. Now this is a homework problem. What was the actual real version? It is not hard version. Real version is, whenever you are at node X, whenever you are at node Y, whenever you are at node Y in your shortest path, you can jump till distance of 2. So guys, now what will you do? The solution will be same old algorithm for pruning of tree. Okay, So what I'm trying to say, lovely student, is that this time the the algorithm is pretty much the same. Like, I hope you guys got what we are trying to say is that. So first of all, we again have to find the shortest path, but this time we can jump two times in the shortest path. Okay. So first of all, what you will do? Destroy all the leaves whose value 0. Destroy this. Let me destroy this also. This is a leaf with value 0, so I have destroyed this also. This is the remaining tree. Now, as per our old algorithm, you know that this leaf is also with value 1, this one, so I will travel these 3 nodes, right? Total is what? Total is 5 minus leaf 2. So 3 nodes, right? You need to visit these 3 nodes, right? As per the old algorithm. When I am here, I will touch this one. When I am here, no need to do anything. When I am here, I will touch this and then I will go back to the start node. Wow! But now we can jump 2 times. So this time the answer is 1 node only. This node. Just being at this node is the answer. Why? When I am at this node, समझो तुम्हारा हाथ है तो तुम दो लेंथ का हाथ बाहर निकाल सकते हो. When I am at this node, I can create a hand of size 2. And this is length 1, this is length 2, and I can collect the coin from here. See, when I'm at this node, I can again create a hand of 2 and collect the coin from here. So this time only one node. So earlier we solved the question when we could create a hand of size 1. But now we can create hand of size 2. So what should we do? Again, very simple algorithm, guys. This time आपको क्या करना है ना? That whatever leaves which you can see now of value 1, whatever leaves you can see now of value 1, you have to delete that leaf. You have to delete that leaf, and leaf will have only one node connected to it. So you need to destroy that node also. You need to destroy that node also. Why? Because these both can be visited. Topic or last step क्या करना है? Whichever leaves have their value as 1, you need to destroy them along with the nodes which are just touching them. Then whatever remaining tree you get, that's the answer. क्या तुमको ये बात पता चला कि लीफ के साथ इस बार जो लीफ के जस्ट बाजू में उसको भी डिस्ट्रॉय क्यों करना पड़ा? क्योंकि उनको विजिट करने की जरूरत ही नहीं है. इसको और इसको दोनों को क्यों डिस्ट्रॉय कर दिया? जो लीफ और क्योंकि यहां से डायरेक्ट इधर रीच किया जा सकता है. समझे? ये लीफ थी 1, इसको भी डिस्ट्रॉय करो साथ में, जस्ट डिस्ट्रॉय द अदर नोड आल्सो. द